Debugging is another place where an IDE can really boost your efficiency. And it's not just for when things go wrong. For instance, you write a new function, when you test that function, you can step through that function line by line, look at all the variables to make sure everything looks right every step of the way. So here we will use Visual Studio Code, but there are other GUI-based debuggers and IDEs out there to choose from. What's nice about this setup is that I'm running Visual Studio Code on my laptop, but you can see I'm connected to a cluster, in this case, the SubMIT cluster. And so this Python file, which we'll look at, actually lives on the SubMIT servers, not my laptop. Moreover, when we actually go to run and debug this file, it'll use the version of Python that I installed in my work directory in a Conda environment on the SubMIT cluster. And so I'll have the familiar GUI experience on my laptop. However, the file both lives and will be run remotely on the SubMIT cluster, not on my laptop. In terms of actual debugging tools, we could, for instance, set a breakpoint by clicking here. That basically means we want to pause the execution of our program at that line of code, so that when we go up here and we select debug Python file, now VS Code does things behind the scene to get everything set up and debugging on the SubMIT cluster. And then it will run our code and pause it here at this highlighted line, which is where we put our breakpoint. So now here on the left, you can see the variables window, which shows you all the variables that are defined and in memory at this particular point in the execution of the program. Another handy variation on this is you can just simply hover your cursor over any instance of any variable, and it'll tell you the value of that variable. Very handy. No more need to write print statements for debugging. And so you can see, for instance, this velocity variable is not yet defined. It's because this line of code has not been run. We can do what's known as stepping, which means you can run the code line by line. So we click this value, this button up here to step. And now we can see that this velocity variable is now defined because this line has been executed. When you come to a function, you kind of have options to either step over or step into the function. If we do step over, this simply will move to the next line and return the value of x max. But let's say we want to actually see what's going on. We can step into the function. And now we see we're paused at this line of code, which is inside this max extension function that was called here. So now you see our variables window looks different because we're inside this function now. These are the variables within the scope of this function. This also brings us to another handy feature, which is the call stack window. So how do we get into this function in the first place? Well, remember, we hit this line of code, and basically our program is, in a sense, sitting there waiting for this function to finish executing so that I can move on from here. So if you want to look at life from that perspective, you can click here on the call stack. And now you see this line of code is executed, and you can see where we were at before this function was called. And you can click here to move the call stack. Now we're back inside this function. And of course, we can continue stepping. Here, let's step into, once again, there's this other function, user-defined function here. So now we're paused inside this function. Now you can see, right, our call stack has grown. We can move up and down the call stack here. And at any point while you're paused, you can add another breakpoint. So that, for instance, if you hit this continue button, this will just continue execution until either the end or when you hit another breakpoint. So let's do that here, and now see that it runs until it hits this breakpoint and then pauses again. Another really handy feature is this debug console, which we'll click on here. And here you can go here and simply type in and execute single lines of code right away. Now, it's more than that because you're actually executing this code from the perspective of this paused line in your program. So you have access to all of these variables and functions at that point of execution of your code. So for instance, we can see what happens if we add one to our spring constant variable. You can also assign values here, so you can change the values of these variables. You can also call our user-defined functions here and interactively change the values and see what happens there. One other point I want to make about breakpoints is that you can actually add what's called conditional breakpoints. which will only pause the execution if some condition is met. So for instance, you can set a threshold value for a variable and only pause if it exceeds some threshold. You can also over here, you can change and tell the debugger to treat exceptions as breakpoints, which is really handy because now if your program hits some unknown error, instead of simply crashing there, it can pause execution. And now you can look at the variables. In particular, you can go up and down the call stack, which is where this can be really helpful, and see what's going on there and see if you can figure out why it crashed. And one thing to keep in mind in the case of Visual Studio Code is that depending on what language you're using, you may need to install an extension to debug in that language. So you can browse the extension marketplace, and please read the documentation for those extensions because some of them require a little bit of setup. We have some tutorials on this on the SubMIT website. And also please keep in mind that there are many more debugging tools than we covered here. This was not meant to be comprehensive, but only give you a brief overview of some tools that might help you in your quest to get more physics done.